At the end of this video, you should be able to explain how the tilt of Earth's axis and Earth's movement cause seasons. Chapter 26, Section 2, The Seasons. Earth's axis is tilted at 23.5 degrees. As Earth revolves around the Sun, Earth's axis always points toward the North Star. Thus, during each revolution, the North Pole sometimes tilts toward the Sun and sometimes tilts away from the Sun, as shown on the screen now. When the North Pole tilts toward the Sun, the Northern Hemisphere has longer periods of daylight than the Southern Hemisphere does. When the North Pole tilts away from the Sun, the Southern Hemisphere has longer periods of daylight. The angle at which the Sun's rays strike each part of Earth's surface changes as Earth moves through its orbit. When the North Pole tilts toward the Sun's rays strike the Northern Hemisphere more directly. When the Sun's rays strike Earth directly, that region receives a higher concentration of solar energy and is warmer. When the North Pole tilts away from the Sun's rays strike the Northern Hemisphere less directly. When the sunlight is less direct, the concentration of solar energy is less, and that region is cooler. Seasonal weather. Changes in the angle at which the Sun's rays strike Earth's surface cause the seasons. When the North Pole tilts away from the Sun, the angle of the Sun's rays falling on the Northern Hemisphere is low. As a result, the Sun's rays spread solar energy over a large area, which leads to lower temperatures. The tilt of the North Pole away from the Sun also causes the Northern Hemisphere to experience fewer daylight hours. Fewer daylight hours also mean less energy and lower temperature. Lower temperatures cause the winter seasons. At the time the Northern Hemisphere tilts away from the Sun, the Southern Hemisphere tilts toward the Sun. The Sun's rays strike the Southern Hemisphere at a greater angle than they do in the Northern Hemisphere, and there are more daylight hours in the Southern Hemisphere. Therefore, the Southern Hemisphere experiences the warm summer season. Equinoxes. The seasons fall and spring begin on the days called equinoxes. An equinox is the moment when the Sun appears to cross the celestial equator. The celestial equator is a line drawn on the sky directly overhead from the equator on Earth. At an equinox, the Sun's rays strike Earth at a 90-degree angle along the equator. The hours of daylight and darkness are approximately equal everywhere on Earth that day. The autumnal equinox occurs on September 22nd or 23rd of each year, and it marks the beginning of fall in the Northern Hemisphere. The vernal equinox occurs on March 21st or 22nd of each year and marks the beginning of spring in the Northern Hemisphere. Summer solstices. The seasons of summer and winter begin on days called solstices. Each year on June 21st or 22nd, the North Pole's tilt toward the Sun is greatest. On this day, the Sun's rays strike Earth at a 90-degree angle along the Tropic of Cancer, which is located at 23.5 degrees north latitude. This day is called the summer solstice and marks the beginning of summer in the Northern Hemisphere. Solstice means sun stop and refers to the fact that in the Northern Hemisphere, the Sun follows its highest path across the sky on that day, as is shown on the screen here. The Northern Hemisphere has the most hours of daylight at the summer solstice. The farther north of the equator you are, the longer the period of daylight you have. North of the Arctic Circle, which is located at 66.5 degrees north latitude, there are 24 hours of daylight at the summer solstice. At the other extreme, south of the Antarctic Circle, there are 24 hours of darkness at that time. Winter solstices. By December, the North Pole is tilted to the farthest point away from the Sun. On December 21st or 22nd, the Sun's rays strike Earth at a 90-degree angle along the Tropic of Capricorn, which is located at 23.5 degrees south latitude. This day is called the Winter Solstice. It marks the beginning of winter in the northern hemisphere. At the Winter Solstice, the northern hemisphere has the fewest daylight hours. The sun follows its lowest path across the sky. Places that are north of the Arctic Circle then have 24 hours of darkness. However, places that are south of the Antarctic Circle have 24 hours of daylight at that time. At this point, you should be able to explain how the tilt of Earth's axis and Earth's movement cause seasons.